Okay, hello everyone. So my name is Eleanor. So I'll be talking about my... Sorry?
You have to hold it here, and you have to speak a bit up.
Okay, here.
Just attach it here.
Okay.
It will stay there.
Okay. Yeah, so hello. So my project is early results on dynamic triggering of seismicity at Sierra Negra volcano in the Galapagos Islands. So how does my project relate to SPIN as a whole? It's looking at dynamic changes in stress at a volcano, and then also relating to material properties and understand how volcanic materials in particular kind of react to stress changes. And obviously, kind of at the heart of all volcanological studies is understanding how volcanic eruptions work and if we can help predict or understand volcanic eruptions more. So a bit of the background of dynamic triggering. So there's been quite a few studies kind of varying in levels of evidence, I would say, of the different dynamic triggering. So this first one is from 2005, and it's looking at the dynamic response of Aso volcano in Japan following the 1999 Chichi, Taiwan earthquake. So these black arrows are the arrival of the P and S waves. This hollow arrow is what they've termed micro earthquakes, which were triggered by the arrival of these P and S waves, and they've separated that out from the aftershocks of the arrival of those P and S waves, which are these kind of grey arrows. And then another study is this one from Mount Etna, and it stated that following the Sichuan earthquake in China, that there was some local earthquake activity at Mount Etna, which then led to an eruption onset. But this is something that we're trying to understand more with dynamic triggering, is because volcanoes have their own kind of seismicity, if it's just coincidental seismicity, or if it's actually triggered by teleseismic earthquakes. And then quickly, this is another study from Alaska. So they found that 9 out of the 12 Alaskan volcanoes did have some form of dynamic triggering response, particularly to the magnitude 9 Tohoku Oki earthquake in Japan. However, they did find hundreds of events where there was no dynamic triggering response. So again, the evidence varies quite a bit, and there seems to be some volcanoes which do kind of have some sort of dynamic triggering response and some which don't. So one which definitely, I think definitely does, is Sierra Negra, so located in the Galapagos Islands. This is the arrival of a magnitude 8.2 earthquake from Mexico. So these are the arrivals of that teleseismic event. And then following that, so this dashed dark green line is the P arrival. You get this local earthquake triggering or dynamic triggering at Sierra Negra. And then all of these light blue lines are what are termed the dynamic triggering events. So again, this is something which they found is related to the Sierra Negra eruption cycle. So they found that as Sierra Negra erupted in 2018, and before that it erupted in 2005, and they found that leading up to the 2018 eruption, this dynamic triggering response increased, so marked by these peaks that you see here, increased up to the 2018 eruption and then dramatically kind of ceased. So that's also something which they're trying to investigate. Key questions of my project. So I definitely want to look into Sierra Negra as much detail as possible. So I want to be able to detect these dynamic triggering events, particularly looking at the most recent data that we have from the volcano. I also want to locate these dynamic triggering events. So as we only have, DIAS only have one station left on Sierra Negra. We did put a temporary network down, but they have all been removed except from one station. So yeah, we only have one station data to go on, so I'll be using the single station method to locate these events. And then how do these events vary? So how do they change in relation to Sierra Negra's eruption cycle? So it goes through a period of inflation and deflation. And it also has a very unique trapdoor fault, which is basically like a fault on a hinge. So it has very interesting kind of stress changes and undergoes very interesting cycles. So I want to see how that relates to its dynamic triggering events. And then how does the triggered events fit into the triggering? So how do the teleseismic arrivals, how do they relate to the actual triggered local events? So are they fitting into a dilatational or compressional period? And then I want to compare to other volcanoes. So is Sierra Negra unique in its material properties? And I want to compare to other global volcanoes, which might also experience dynamic triggering. So yeah, very quickly, I am, as I mentioned, doing event detection using a simple STA-LCA algorithm. So again, I'm applying this to the dynamic triggering events that we already know occurred. And then, however, I applied it to the Japanese earthquake, which happened a few months ago. And as you can see here, this is kind of the arrival from that. And it looks quite different to the sudden dynamic triggering kind of jumps that we get here. So again, it could just be a coincidental earthquake swarm that happened at Sierra Negra and just happened to occur at the same time as the arrival of that event. Yes, so thank you very much. I welcome any questions, or you can come to my poster or talk to me on Twitter or email. Yes, thank you.